Hello, hi everyone. Welcome to the Student the Brand. This is your Shiva sir. So today topic is work, energy, and power. Work, energy, and power. Okay. So what is work? What is work? What is work? So daily we do so many works. So walking, running, jogging. These are all works. You are holding the bag and carrying from one place to another place. So changing the bench, pushing the bench, carrying the vegetables, carrying the groceries from shop to home. This all we are doing work, right? And we are sleeping also sometimes. That is also work only, right? Yes, sleeping, wake up, doing, writing notes. Okay, so listening class, so practicing, preparing for exams. These are works. Okay. Yes. So work is nothing but when we apply force on the object moves from one place to another place. When we apply force on the object moves from one place to another place, then we can say work is done. Yes or no? So we will make the object to move from one place to another place with respect to time. When we apply force on the object moves. Okay, so when from one place to another place. Yes or no? So okay, so I'm taking the object here. Work. Today topic is work, energy, and power. Work, energy, and power. Okay, so grade 11 physics. So far it will also helpful for JEE and NEET students. Okay. And actually we have to do problems also related to that one. So first we will discuss about concepts. Later we'll go for problems and applications, everything. So work. Yes. How many are there? Positive work, negative work, zero work. How many are there? Positive work, negative work, zero work. Yes or no? Yes. Sir, we know work. We know work. We know work. Yes or no? Sir, what is positive work? What is negative work? What is zero work? So here I am taking an object. So here you can observe. So I am taking this object. This object. Yes or no? We are applying force on the object. This is the force. So body is moving here. Understood or no? So the angle between force and displacement is theta. Angle between force and displacement is theta. Understood or not? Yes. Angle between force and displacement is theta. When we apply force on the object moves. Object moves. Yes or no? How it is moving? Horizontal direction. So we're resolving the components. So we'll go to the resolving the components. Okay, vectors. So this is the x-axis, y-axis. So x-axis, y-axis, right? So here you can observe this the y-axis, and this one is the force. This is the force F. Okay. So we are resolving the components along x-axis and y-axis. This is the theta. Along x-axis and y-axis, we are resolving the components. Yes or no? We are resolving the components. Force into two components along x-axis and y-axis. Yes or no? Along x-axis and y-axis, we are resolving the component force into two components. So here you can observe this is x and this one is y. X and y. Now cos theta formula. What is the cos theta formula? So here you can take this x component along x-axis. So here this x, this along x-axis direction, and this is along y-axis. Okay. So now cos theta, what is the cos theta formula? Cos theta equal to adjacent side by hypotenuse. Hypotenuse is the force. Okay, so x equal to f cos theta. And coming to the sin theta equal to y by f. That is equal to y equal to f sin theta. Understood or not? F cos theta and f sin theta. So along horizontal direction, the component of force which is acting, that is f cos theta. Okay, f cos theta is acting along the horizontal direction. F cos theta. Okay, so along horizontal direction, so f cos theta is acting. So because of that reason, when we apply force on the object is moving horizontally. When we apply force on the object moves horizontally. Okay, so along the displacement, okay, along force applied direction only it will move. So which component of force is responsible for the movement of the body? Horizontal direction. Okay, horizontal direction, along horizontal direction, the force component is acting. That is F cos theta. F cos theta is responsible for the movement of the body. Sir, what about Y component? At that time, still Y component is there, but so there is no impact on movement of the body, but horizontal component is responsible for the movement of the body. When it is moving upward direction, when we are moving upward direction, so vertical component is responsible for it. Okay, if you are applying like this, say if it is moving upward direction, then it will be. Okay, yes. So now we can observe, now force, okay, work done equal to F bar dot S bar. F bar dot S bar. So vector notation. Vector notation. F bar dot S bar. Okay. So F bar dot S bar. W equal to F bar dot S bar. Now W equal to Fs cos theta. W equal to Fs cos theta. I hope it is very clear. W equal to Fs cos theta. So here separately if you want to me write, I will write like this. F cos theta into S. So because horizontal component along x-axis, that is F cos theta into S. Then W equal to Fs cos theta. W equal to Fs cos theta. I hope it is very clear. W equal to Fs cos theta. Is it clear? So that is work done. That is work done. Understood or not? Now here there are three types of work done. One is positive work done, negative work done, zero work done. First point is positive work done. Second one is negative work done. And third one is zero work done. Oh, okay, work done are three types. Positive, negative and zero. Positive, negative and zero. So when it will be positive, when it will be negative, when it will be zero. So when we apply force on the object, so here, so I am taking like this. When we apply force on the object, so force and displacement are acting in the same direction. Then in this case theta equal to 0. So first case theta equal to 0. Then W equal to Fs cos theta. W equal to Fs cos theta. Understood or not? W equal to Fs cos theta. So theta equal to 0. theta equal to 0, W equal to Fs cos 0, then that is equal to Fs. So work done is maximum. Work done is maximum when the force and displacement are acting in the same direction. So when theta equal to 90 degrees, work done is 0. Work done is 0. So W equal to Fs cos theta, W equal to Fs cos theta, Fs cos theta, okay, cos theta equal to 90 degrees, Fs cos 90 degrees, then W equal to Fs cos 0, cos 90 0, then total becomes 0, so work done is 0, okay. So when it will be negative work done, when force and displacement are acting in opposite direction, when force and displacement both are acting opposite direction, okay, that time work done is negative. So here positive theta equal to 0, so 0 theta equal to 90 degrees, and here theta equal to 180 degrees, so between force and displacement. Understood or not? So now you can see here, so W equal to Fs cos theta, so theta equal to 180 degrees, then W equal to Fs cos 180 degrees, Fs cos 180 degrees, then W equal to minus Fs. Work done is negative. Positive work done, negative work done, and 0 work done. When it is positive, so when force and displacement are acting same direction, then work done is positive. When force and displacement perpendicular to each other, angle is 90 degrees, then work done is 0, because cos 90 is 0. So when it is negative, when the force and displacement are acting in opposite direction, then theta equal to 180 degrees, that time work done is negative work done. Understood? So these are the points: theta equal to 0, theta equal to 180, theta equal to 90, positive work done, negative work done, and 0 work done. Understood or not? So this is about work done, positive, negative, and 0, right? Yes. So now we will discuss about energy. So we'll discuss about energy. So let's start discuss about energy. So energy is nothing but ability to do work or capacity to do work. Energy is nothing but ability to do work or capacity to do work. Ability to do work or capacity to do work is called energy. So I hope it is very clear. Positive work, negative work, and 0 work. So if the body is moving in a round trip, the work done by the force is not 0. Okay. Force, displacement, work done. Okay. Now we'll discuss about energy. So what is energy? Ability to do work or capacity to do work. Ability to do work or capacity to do work is called energy. What is energy? Ability to do work or capacity to do work is called energy. So energies are different: heat energy, mechanical energy, thermal energy, like solar energy, wind energy. So like there are so many. So here we are discussing about mechanical energy. So what is mechanical energy? Sum of kinetic energy plus potential energy. Sum of the kinetic energy plus potential energy. First one is kinetic energy. Kinetic energy. Kinetic energy. So second one is potential energy. Potential energy. Potential energy. Coming to the kinetic energy, energy possessed by the body by virtue of its motion. Energy possessed by the body by virtue of its motion is called kinetic energy. Okay, so motion. And coming to the energy possessed by the body by virtue of its position or configuration. Energy possessed by the body by virtue of its motion is kinetic energy. Energy possessed by the body by virtue of its position is kinetic energy. Sorry, potential energy. Kinetic energy related to motion. Potential energy related to position. Okay. So now we will derive the relation. So equation of kinetic energy. Equation of kinetic energy. So what is that one? So we will see. Kinetic energy. Kinetic energy. Okay, so kinetic energy. Kinetic energy. Understood or not? So here I am taking like this. So this the object. The position of the object is at A. So initial velocity is U. Initial velocity is U. So position of the object is at A. And after a certain time, it reaches to position B. So final velocity is V. So object is at position A, initial velocity U. After reaching certain distance, so here it is traveled to certain distance here. This is S. Okay. Now here acceleration is there. Acceleration. Okay. Understood or not? So from equation of motion, we know V square minus U square equal to 2AS. And S equal to V square minus U square by 2A. Okay. So anyway mass is same, M only. Mass is not changing. Body mass. And we know force, work equal to force into displacement. Okay, when we apply force on the object moves from position A to position B. Okay, so here, so whatever the work is done on the body, okay, that will be converted in the form of kinetic energy because the body start moving. Okay, body comes under motion. Then kinetic energy, K equal to, we know from Newton's second law, F equal to ma. Okay, so the net external force acting on the body is equal to mass of the body and acceleration of the body. So ma into S. S is nothing but V square minus U square by 2A. And here A get cancelled. Here you can see A get cancelled. A get cancelled. Then K equal to M into V square minus U square by 2. That is K equal to, so MV square minus MU square by 2. Then K equal to half MV square minus half MU square. Half MV square minus half MU square. Okay. So I hope it is very clear. Understood or not? So check once here. Check once. So kinetic energy possessed by the body by virtue of its motion is called kinetic energy. Okay, so position A and it reaches to final position B. And Newton's second law, F equal to ma. Okay, V square minus C square equal to 2as. From S equal to V square minus C square by 2a. Whenever force is applied, the body moves. So that is W equal to Fs. So whatever the work is done, that will become in the form of kinetic energy because the body comes under motion. Okay, then K equal to ma into, so v square minus v square by 2a, a get cancelled, then you'll get. So if the body is starting from rest, initial velocity 0. Initial velocity 0 meter per second. Okay, then you can take this entire terms become 0. Then K equal to half m square. K equal to half m square. Understood? So that is the kinetic energy formula. K equal to half m square. K equal to half mv square. So this is the formula of kinetic energy. Energy possessed by the body by virtue of its motion is called kinetic energy. Energy possessed by the body by virtue of its motion is called kinetic energy. Understood or not? So that's enough. Next one we will discuss about potential energy. So this is related to kinetic energy. So now we will discuss about potential energy. Okay, potential energy. So potential energy is nothing but potential energy is nothing but potential energy. So potential energy. So energy possessed by the body by virtue of its position is called potential energy. So here I am taking the object here. So like this is the object. Mass of the object is m. So it is lifted until certain height. So same mass. The height of the object is h. So h. And a equal to acceleration due to gravity. A equal to g. Okay. So now we know W equal to force into displacement. Whatever the work is done, so that will be converted in the form of potential energy. So P equal to ma into s. S is nothing but h here. So how much distance it is traveled in the form of height. So that is h. So P equal to, we know m, a is nothing but g, because again against the acceleration due to gravity the body is moving. So this is about potential energy. Okay, so P equal to mgh. P equal to mgh. Understood or not? I hope it is very clear, right? Next one, power. So we'll discuss about power. The rate of doing work is called power. Rate of doing work is called power. So P equal to W by T. So power equal to rate of doing work. SI unit of power is what? SI unit of power is what? Okay. SI unit of power is what? Is it clear? 1 horsepower equal to 746 watt. So that's enough. This is about work, energy, and power. Work, energy, and power. So I hope it is very clear. So if you like the content, if you like the channel, so please do like, share, and subscribe to Student the Brand. If you like the content, if you like my explanation, so do like, share, and subscribe to Student the Brand. Share to everyone, inform to everyone, ask your friends to join to the class. So this is your Shiva sir from Student the Brand. Thank you so much for joining and attending and listening my class. So we'll see you in the next class. Thank you.